Let's talk about time window compaction. One of my favorites. Why? Because it's kind of fun, but it's really useful. It is purpose-built for one type of data model, and that's time series. And as you see how it works, you'll see why it's so good for that. It really takes advantage of a lot of things Cassandra can do, but also takes into account why you're using a time series data model. Let me explain. So here is a great animation of what time window compaction does. Hold on to your hat. There's a lot of data flying around here, but hopefully this will make sense for you. So time windows. We're looking at when data arrives on the system. We're starting at 3 p.m., but where do we end? That time window, that concept, what window is it? Well, we get to choose windows of certain sizes. In this case, in this example, we're going to use a 1 hour window. We're saying this window of time is significant. So from 3 o'clock to 4 o'clock. So as we're writing data at 3 o'clock, we hit the 4 o'clock mark. It will then compact all of the SS tables into one SS table that marks 3 p.m. to 4 p.m. So that time window now is compacted and done. As we move to the next window at 4 p.m., here's a whole bunch more files. Now, look what it did here. It actually did a size tier compaction inside of that window of time. That is one of the features of time window compaction. Inside of that hour, if you're writing a lot of data, instead of just creating a whole bunch of little tiny files, it's still going to run size tier compaction inside of that hour. Now, what happens when we hit the hour? 5 p.m., here's another window. It compacts all of the data inside of that window. See where we're going here? More data is written, more data is compacted, more data is written, more data is compacted, until you guessed it, we hit the next hour mark. At 6 p.m., what do you think is going to happen? I'll let you guess. That's right. It does a compaction. And it just keeps doing this over and over again. And what we wind up getting here is over time, as we're writing a lot of data in the system, it's creating these windows of data. And that's really important whenever we're reading that data. If I'm looking at this and saying, when am I going to find that data? Well, we're just going to look at a certain time window. And that data never has to be compacted ever again. At this final state where all my data is here for the day, because it's a time series data model, I'm not expecting there to be any tombstones. I'm not expecting there to be any overwrites. I'm saying this data is fairly immutable, but I want to have it grouped up in a way that I can move it away from the compaction process and never be compacted again. So once I go outside of that hour window, it's never touched again. This greatly reduces the amount of disk I/O on a really fast-moving time series data model. So some of the details here. An SS table over those two windows, well, we just go back to that second window. It's just that simple. We're not trying to be too fancy, or it doesn't split it or do anything like that. We want to go for 50 or so SS tables on disk within the window. So this is how you compute how big of a window you want. The reason being is because when you get to that hour window or whatever that window size is, you have to compact that many files. So if you create a window, say like 1 day, and there's 3,000 files in there, at the end of that day, it's going to be a very bad moment for that computer. It's going to be doing a lot of compaction. So let's give it a break. Think about what you're going to do to it. Have a little empathy. Keep it to 50 files. Some of the tuning parameters are really just the Windows unit. Minutes, hours, and days. And then the window size. Those are it. And that's the simplicity and beauty of time window compaction. So I want to do some really granular stuff, like I want a 10-minute window or a 15-hour window, something like that. Great. It's very simple, and it should fit in your head. This is just the window of time that I want, and this is what I want to compact. Another area of tuning, which is probably the bigger problem, is looking for tombstones. Tombstones, as you know, are deleted data, and those can tend to pile up. If you have an SS table out there with a lot of tombstones in it, this could be a problem in time window. So we check that. It starts looking for those to clean them out. Now, this is a bit of an anti-pattern. If you're going to use a lot of tombstones, think twice about using time window compaction. You're going to create a lot of data that's just going to sit there until it finally gets compacted, and it may not get compacted for a very long time. So this is a good overview of time window compaction, and I think the animation really makes it here. That's something you need to see working, but it is really simple. Here's a window of time, compact all my data inside of it, leave it alone, put it aside, don't touch it. That's what you really want in a time series data model. I'm done with this data. I just want to read it later. Put it aside. Don't mess with it anymore. Time window compaction strategy is the don't mess with it compaction strategy, and it can be really helpful. So when you have a time series data model, think about using time window compaction strategy.